Dear students, in this video, I am going to explain about lesson number 2, Quantum Mechanical Model of Atom, topic number 8, Main Features of Quantum Model of Atom. In my previous video, we discussed about Schrödinger wave equation. There, we saw that the Schrödinger wave equation overcome the drawbacks found in the classical mechanics by introducing a new mechanics called quantum mechanics. So following that, here we are going to talk about the salient features of the quantum mechanical model of atom. So the first important point is the energy of electron in an atom. As per quantum mechanics, the energy of electron in an atom is quantized. Quantized means they have fixed energy. They have small packets of energy. The energy is not given with the full amount. The energy of the electron is in the form of discrete pattern. That is called as quantized. We know very well that around the nucleus several orbits are there. First orbit, second orbit, third orbit, fourth orbit. That is represented as K shell, L shell, M shell, N shell. And each and every orbit has certain number of electron, fixed number of electron. And those electrons will have fixed energies present in them. That is called as quantized. The existence of quantized, this type of existence of quantized electronic energy level around the nucleus shows the wave-like property of electrons. We know very well that as per the de Broglie concept, electrons and all the microscopic and macroscopic particle has dual character. But here, as we see here, the quantized electronic energy level is a direct result of wave-like property of electron. The solutions for Schrödinger wave equation gives the allowed energy level or orbits. Governing the Heisenberg unsanitary principle, that is, what does the Heisenberg unsanitary principle says? By following that, the quantum mechanics introduced a concept called orbital. What is called as orbital? Orbital is a three-dimensional region of space around the nucleus where the probability of finding electrons are maximum. So these are the several orbitals. We know there are 4 orbitals are there: s orbital, p orbital, d orbital and f orbital. S orbital will be spherical in shape, p orbital will be dumbbell in shape, d orbital will be double dumbbell or clover leaf or definite shape, and f orbital will be diffused shape. These are some of the important shapes of the orbitals. So this orbital concept was given by the quantum mechanics by following the Heisenberg unsanitary principle. The solution for Schrödinger wave equation for the allowed energy level of atom gives the wave function psi. The wave function psi is the important function which is used in the Schrödinger wave equation. This wave function is obtained by the allowed energy level values through the Schrödinger wave equation, which represents the atomic orbital. The wave function value gives the atomic orbital. The different atomic orbitals are there, no? Those atomic orbital values are given from the wave function. That wave function is obtained from the energy levels of the atom around the nucleus in different cases. The wave nature of electron present in an orbital can be well defined by wave function psi. The wave nature of electron in an orbital, let us imagine the electrons are moving around the nucleus in wave form. The wave nature of the electron in an orbital can be defined by the wave function psi. So see this diagram. 4 orbits are taken. N is equal to 3, N is equal to 4, N is equal to 5, N is equal to 6. In each and every orbit, the wave nature of electron get differ. Based on that, the wave function psi value also get differ. Okay, this is one of the important feature of the quantum mechanical model of atom. The wave function psi has no physical meaning. Psi is nothing but it is a function. It represents the function of the wave with respect to the x, y and z axis. That's all. We don't have any physical meaning for the function wave for the operator called wave function. However, the probability of finding electron in a small volume, that is dx, dy, dz around a point x, y, z is proportional to psi of x, y, z the whole square into dx, dy into dz. Here, the psi of x, y, z the whole square is known as probability density and is always positive. Probability density and it is always positive. Probability density அப்படினா வேற ஒண்ணும் கிடையாது. நியூக்ளியஸ்ல இருந்து எவ்வளவு தூரத்துக்கு அந்த எலக்ட்ரானோட டென்சிட்டி இருக்கும். For example, let us take 1s orbital. 1s orbital is nothing but the electron present in first orbit s sub shell. it is very very closer to the nucleus. Being first orbit, it will be very closer to the nucleus. அப்போ அந்த நியூக்ளியஸில் இருந்து எவ்வளோ தூரத்துக்கு அந்த எலக்ட்ரானோட டென்சிட்டி 1s ஆர்பிட்டலில் இருக்கக்கூடிய எலக்ட்ரானோட டென்சிட்டி இருக்கும் அப்படின்னு சொல்லி சொல்கிறது பேர் தான் என்னது, நமக்கு இந்த வேல்யூ வந்து psi into x y z the whole square அப்படின்னு சொல்லி சொல்கிறோம். சரியா, ஸ்கொயர் ஆஃப் த wave function gives the probability density of the electron. Wave function has no physical meaning, psi has no physical meaning, but the square of the wave function gives the probability density of the electron. எந்த அளவுக்கு எலக்ட்ரானோட டென்சிட்டி நியூக்ளியஸை சுற்றி இருக்கும், எவ்வளோ தூரத்துக்கு இருக்கும் அப்படிங்கிறத ப்ராபபிலிட்டியை பற்றி சொல்கிறது தான் என்னது, square of the wave function, that is probability density, and it always have positive value. So see here, I have given the shapes of three different orbital, s orbital, p orbital and d orbital. S orbital has spherical shape. In 1s orbital we have a orbital around the nucleus, and in 2s orbital we have two spherical orbital. Near to the nucleus we have 1s spherical orbital, and after that some empty space will be there, and after that empty space we will be having the spherical 2s orbital. What is the empty space between the 1s orbital and 2s orbital? It is nothing but node. The empty space that is left between the 1s spherical orbital and 2s spherical orbital is called as node. Node means it is a three-dimensional region of space where we can't able to find any electrons at all. What about 3s orbital? In 3s orbital, around the nucleus we have 1s orbital, and next to that 2s orbital, and next to the 2s orbital we have a spherical 3s orbital. In between 1s, 2s and 3s we have two nodes present in it. So the number of nodes present in an orbital is equal to n minus 1. எத்தனை ஆர்பிட் இருக்கோ அதுலேருந்து ஒரு ஒன்றை சப்ராக்ட் பண்ணிட்டு அப்படின்னா நம்பர் ஆஃப் நோட்ஸ் கிடச்சிரும். இன் 3s ஆர்பிட்டல் we have 3 orbits, so number of nodes will be 2. For 2s orbital we have 2 orbit, the number of nodes will be 1. For 1s orbital we have only 1 orbit, we don't have node at all. Then coming to the p orbital has dumbbell shape. It has 2 lobes where the electron density will be higher, and the point where the 2 lobes meet together, will have zero density for the electron. That is called as nodal point. This is called as the nodal point, the point where the 2 lobes meet together. We can't able to find electrons there, so it is called as nodal point. So there are 3 different type of p orbital. One is facing towards the x-axis, and another towards the y-axis, and another towards the z-axis. So based on that, px orbital, py orbital and pz orbitals are labeled. And what about d orbital? D orbitals has 5 different orientation: dxy, dyz, dxz, dx square minus y square, and dz square. And all the d orbital have 4 lobes present in it, so it is called as double dumbbell, or it may be called as a clover leaf shape, or it may be called as a duck nut shape. So these are the probability density of electron around a nucleus in various shapes and various energy levels. This idea was given by the quantum mechanical model of atom, and it is one of the important feature of the quantum mechanical model of atom. Thank you.